Conjugate pairs. That means there's two things if you got a pair. So anytime you have pairs of complex zeros, remember those are the same thing as saying you have imaginary zeros. So that means if you have some i's involved, those are called conjugate pairs. And what that means, for example, is if you have a 3i, then you must also have a negative 3i. If you have a 1 minus I radical 2, then you must also have a 1 plus I radical 2. So you always have to have a positive and a negative. So whenever you have to find a polynomial with given zeros, a lot of times it's not going to give you both. I don't know why they like to do this, but they just want to make you think. So you're not going to have both, you're going to have just one of them. Now notice we need to find a fourth degree polynomial. So that means we need to have an x to the fourth. We are given the zeros of -1, -1, and 3i, but we also have a negative 3i. It just doesn't tell you that. But we need to have fourth degree, so we need to have 4 terms and 4 factors. So we're going to start off with, well, if you have a polynomial, you have to set it equal to something. So we're going to set it equal to f of x. So if you're given a 0 of -1, that means your factor is x plus 1. Given another -1, so we're going to put plus 1. Now your 3i, that is saying x minus 3i. If 3i is your 0, your factor is the opposite sign, and then you'd have an x plus 3i. So if we want to simplify this, easiest thing to do would be to multiply the first two together, and then we're going to multiply the second two together. Nice part about this, when you set it up correctly, you have a nice little easier shortcut here on the front. So we're going to say, well, x plus 1 times x plus 1, that gives us x squared plus a 1x plus another x plus a 1. And then in the orange, this is a difference of squares. So for your difference of squares, you take x times x, which is x squared. And then if you you have a minus sign. So what you're going to do is you're going to take 3i, and you're going to square that also. This is just your difference of squares that you've dealt with in Algebra 1 and Algebra 2. So let's clean this up. In the first set of parentheses, we're going to have x squared plus a 2x plus 1. And then your second set of parentheses, you're going to have an x squared minus, now 3i squared is a 9i squared. And you have to remember that whenever you have an I squared is equal to -1. So what really happens if you put a -1 in for I squared, that's a -9 times a -1. So what I like to do is anytime I have an I squared, I just mark out the I squared, change the sign in front of my coefficient in front of my I squared. That's all you're doing. You're multiplying by -1, which just changes your sign. So we're going to have x squared plus 2x plus 1. And notice that we have gotten rid of all of our i's. Ouch. Both i's. It's going to leave a mark. So if we distribute x squared times an x squared gives us an x to the fourth. There's your fourth degree polynomial. Plus a 9x squared. And then we go to 2x times both those. You get a 2x cubed. And then you have an 18x. And then we have a 1 times x squared and a 1 times 9. So finally we can simplify. Do not forget saying f of x is equal to something. So you're going to have x to the fourth plus 2x to the third. So I like to mark them out after I add them. That's gone. That's gone. We're going to add 9x squared and a 1x squared. Should give us a 10x squared. And then you have an 18x plus 9. Boom. There we go. And that's how you find a polynomial with your given zeros, especially whenever only one of them is given to you as an I. Remember, you should always have 2. You have 2 i's. Some of you 4, I know. Sorry, bad joke. I'm out of here.